This G of F is band limited. I can use the formula H of omega is 1 over T times P Rx of F, P Tx of F times G of F, all right? But this guy here, we 1 over T times, this is, because this is this guy star, that's P Tx of F star times, or just, okay, I'll write here. 1 over 2 pi j f plus 1 over t. All right. Actually, I'll write it properly. P, so this guy star. Okay, so I just substitute every one of these equations in here. So this is just this times this star, so that's this magnitude. So that's G naught over 2 pi, and that is one over t squared. But I have to substitute, remember that F is equal to omega over 2 pi t. All right, so if I substitute that in here, that's G naught over T times J omega divided by T, all right, and plus 1 over T, all right, is squared, right, rect of omega over 2 pi. Does that make sense to everyone? Now we have a trick here. We can pull the t's out, all right, and then that'll pull a t squared out, and then we'll get, so that'll be g naught over g naught times t. This is and then I'll have an omega and plus 1. All right, so I'll skip, not do too many steps here, right? Right, and this guy here, note that rect of omega over 2 pi will be 1, okay, and times 1, okay? Because remember that rect will be 1 for omega over 2 pi less than a half, right? And, okay, so does that make sense to everyone? Or did I use any one of this part?
Could you repeat what you
Okay,
just said?
Because this is kind of a standard trick. Now, because rect of omega over 2 pi is equal to 1 when absolute value of omega over 2 pi is less than 1/2, which is that's the same as omega is less than pi. But this whole, so for omega but omega here, we're only interested in omega between minus pi and pi. So this guy's, okay. So this guy here is equal to g naught times t times, what's the absolute value of that, magnitude squared of that? How do I take that magnitude squared of that complex number? What's the magnitude squared of like a plus jb?
A squared plus g squared.
Okay, what's the magnitude of this?
Omega divided by 3.
Omega squared plus 1 squared.
Yeah.
All right. So I get this value here. No. Okay. So now I have the effective discrete time chatting.
How did I know that omega divided by 2 pi is less than 1/2?
Because this is only for, so I say it's effective discrete time channel. Let's say because I'm only interested in, I should write this here, for omega less than pi, right?
Oh, okay.
Okay, now the reason why we're only interested in this region is because when we want to compute the channel coefficients, we only need it in this region.
But that's assuming that we have from minus pi to pi, not from 0 to 2 pi.
That's right.
Okay.
That's correct. All right. So, what are we on? B, C, E. Write a formula for write a formula for HK, basically. All right. I would not ask you to write the integral, but just take the inverse of this. So HK in this case is 1 over, is basically the HK is equal to the I dt ft of h of omega, which is equal to 1 over 2 pi times the integral from minus pi to pi g naught t plus 1 of e to the d of omega. All right. You could, I'm sure there probably is a way to evaluate that. I just don't know how to do it. It doesn't matter. So I would only ask when you exactly write it like this. Is there ISI? Is there ISI in this channel? Yes or no?
No.
No? Well, okay, when is there ISI? There's ISI whenever these coefficients are non-zero. When there's non-zero coefficients for k not equal to 0. But this clearly will, because the only way you get ISI, don't get ISI, if this is a constant function. Yes?
What's ISI stand
Intersymbol interference.
for? Okay.
All right. The only way you get a is okay, so there's ISI, there's no ISI implied, it's only true. So that's probably too low, so let me write it up here. No ISI implies that HK is equal to some is 0 for all k non equal to 0, right? In other words, that HK is equal to some constant times, well, H0 times delta k, right? Because it just means that it only has a value at, not at 0, all right? And it only has a value at 0. But then if that's the case, what is h of omega? If this was the case?
1.
Well, if it's h, yeah, so that would imply that h of omega would be h naught, a constant. So that means it has to be constant, right? But in this case, h of omega is not constant with omega. It changes with omega. So this is like a no ISI channel is often called a flat channel, all right? That means that it looks like this, all right? Here's like, here's minus pi, right, to pi, right? It's actually a periodic function, so it looks like this, right? And then with ISI, like in this case, if you were to graph it, all right, it would look like this. So it changes with frequency here, right? So if it changes, all right, once it's no longer flat, then there will be ISI. Okay. So what other kind of problems I can do? The only variants I can do are basically give you ways that you have to compute one of these or something like this. And the other thing is, so, you know, I could make you go back to, does everyone understand this problem? So everything else is like too much math for an exam. I mean, they're just like, I'll just have you write that expression. So some of the key formulas, you want to put this formula on your notes, all right, with omega, and then you want to put the ID TFT formula, but then you probably won't have to take any ID and TFTs, all right, unless it's something really, really simple. Okay.
Sandeep,
Yeah.
are we gonna have MATLAB questions in the final?
Yes, for the demodulation, just similar to, because you did, but only stuff you did from the lab. The only lab that you did was the demodulation lab, all right?
Okay.
So just the only one
Okay.
that you have. Okay, so they'll be on that demodulation part. So what is it? There's the demodulation in the code. Okay. So are we good with this? Should we do one more problem? Okay.
Sandeep,
Yeah.
so I know that this is not constant, like h of omega is not constant, but what is the main reason why it is a constant here?
Why would it be constant? When would it be constant? Is
No,
that
like
the question?
what is the formula or the function that made this not constant?
Oh,
like in
this
here?
function here.
Okay.
See, that's an omega squared. So if you were to graph it, it's g naught over t at 0, all right? Maybe I will tell you graph that function. It's g naught over t, and then it goes down as omega goes to 0 to 5,
Okay.
all right?
So if we had sync, for example, would it would be flat?
Then it would be flat, exactly,
Okay.
and that's why you get no ISI, right? So, okay. Okay, let's say that, okay, let's do another one. Let's say that I give you, I don't know, let's give another function. It's kind of simple to do. Let's say that it's, what's something that's easy? Okay, let's do, okay, let's do the following function. Let's say it's, oh yeah, let's do a graph. I mean, everything else is fine. Or actually, let's do the following. All right, so it's graph of t, one is ERX of t for a math filter. Draw okay. Is all right. So this is easy. This one's easy. I just go P R X of t is rect is, well, I'm just writing for it, but yeah,